Assalamualaikum warahmatullahi wabarakatuh. Good night, all my friends. Innalhamdulillah nahmaduhu wa nasta'in wa nastaghfir wa na'udzu billahi min sururi anfusina wa min sayyiati a'malina. May yahdihillahu fala mudhillalah wa may yudhlil fala hadiyalah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. La nabiyya wa la rasula ba'da amma ba'du. Honorable Ustadz and Ustazah in Fisika subject and my dear friends, kelas 11 MIPA 1, and all praise and pray for the presence of Allah Subhanahu wa Ta'ala, who has bestowed His mercy on all of us so that we can gather on the discussion. Praise and greeting, and do not forget, let us praise our Lord the Prophet Muhammad Sallallahu Alaihi Wasallam. Okay, before that, let us first introduce ourselves. We from the group want to present about our Fisika project for our optical instrument, namely the camera. In our group, there are 6 people, namely Muhammad Willan Mukholadun, Muhammad diky ramadhani, abiyyufaiq anasmy, haryo dzaki adani, Muhammad aufa, and raihan, cahaya, haryo, hangsoka. Okay, let's just go straight to our discussion material tonight. Langsung ke PPT-nya, Dik. Number 1, camera history. The camera was first discovered in 2008 by a Muslim scientist named Al-Haytham with the first camera named Obscura. This camera obscura was developed with the concept of a small hole in a dark box illuminated by light which then was able to produce an image. Number 2, description of camera. A camera is a device for filming and recording a portrait image on a sheet of film. In a television camera, the lens system forms an image on a light-sensitive plate.
Number 3, components of camera. There are various components of camera, but here we will mention only a few. That is camera body, lens, shutter button, viewfinder, LCD lens, battery, on or off button, dial mode, main dial, menu button.
Number 4, how the camera can work. The camera takes all the reflected light and asks that light to create an object from the direction the camera is looking at. And when all the light collects on a sheet on film, it will produce an image of the object.
Five, problem example. A single lens analog camera has a focal length of 10 cm. Initially, the camera is set to take picture of object infinitely far away. If someone wants to use the camera to photograph an object 5 meters away, counted is now the focal length of the lens f sama dengan 10 cm and 100 millimeters. The distance between the film and the lens when the camera is set to shoot an object is infinite. 2. The distance between the film and the lens when the camera is set to shoot an object within 100 meters. And 3. Change the lens position for infinity setting to 100 meters setting. The lens is moved away from the film or towards the film.
Answer the problem. Number 1. The distance between the lens and the film. The image distance, the accent, the local length. F of the lens, 100 millimeters. Number 2 is known. Object distance, 5 m sama dengan 5,000 millimeter. The focal length of the lens, 100 millimeters. Number 3, the distance between the lens and the film is number 100 millimeters. 100 millimeters. When set to shoot objects within 5 meters, the distance between the lens and film is 102 millimeters. Thus, the change in the lens distance from the film is 100 millimeters. Mean serat 100 millimeters, 2 millimeters.
Problem example. Two convex lenses respectively have a focal length of 40 mm and 20 mm. Both lenses are used on analog cameras to photograph an object 10 meters away. Specify is now the focal length of the one convex lens f1 equals 40 millimeter. The focal length of the two convex lens and f2 equals 20 millimeter. Object distance equals 10 meter equals 10,000 millimeter. For the distance between the film and the lens with a focal length of 14 millimeter when the camera is set to shoot object. Also calculate linear magnification. 5. The distance between the film and the lens with a focal length of 20 millimeter when the camera is set to shoot object. Also calculate linear magnification. answer the problem. Number 4, convex lens equals 1 per S equals 1 per F minus 1 per S equals 1 per 40 minus 1 per 10,000 equals 250 plus 10,000 minus 1 per 10,000 equals 249 per 10,000. S equals 10,000 per 214 equals 40.2 millimeter. Magnification linear or M. M equals S per S equals 40.2 per 10,000 equals 0.004 times 0,004 times. Number 5, convex lens or 1 per S equals 1 per F means 1 per S equals 1 per 20 means 1 per 10,000 equals 500 per 10,000 mean 1 per 10,000 equals 499 per 10,000. S equals 10,000 per 499 equals 10 with 20.0 millimeter. Magnification linear or M. M equals 20.0 per 10,000 equals 0.002 0,002 times.
Okay, we have arrived at the end of the presentation program. Here we from group 1 apologize for the leak of presents and apologize also for the mistakes we said before. Before I close this event, let me tell my friend, my name is Muhammad Wildan Mukholadun. In this group has a duty to make a PPT, so he do not participate in the presents part. Okay, that's all for us. Wassalamualaikum warahmatullahi wabarakatuh.